Welcome to How We Made That App, where we explore the stories behind the apps reshaping industries and driving innovation. I'm your host, Madhukar Kumar, Chief Marketing Officer at SingleStore. Today, we are joined by Ronald Ashri, Founder and Chief Product and Technology Officer at OpenDialog, a company revolutionizing conversational AI. If you're passionate about tech, AI, or app development, this is the podcast for you. Let's dive in. Hi, Ronald. Welcome to the episode and thank you for joining us. So let's get started. I'm pretty curious and excited about learning more about what you're currently doing because it involves a favorite topic of mine and, of course, everybody else's is agents. But
hmm
before we get started, tell us a little bit about your background, your journey. Where did you start? How did you become a developer? And what led you to here?
Um, sure, of course, and thank you for having me. It's great to be here. So I'm a technologist. I studied computer systems engineering at university. Some time ago, I'll let people guess the exact date. But the one thing I will share is that as I was doing my computer systems engineering degree, and I got into the third year, I wanted to do more AI and I wanted to do cognitive science from the psychology department. And I got
Wow.
pushback because AI was not popular back then, and people were concerned about how computer sciencey it would be if I brought in cognitive science and too many AI modules into my course. So that was the context when I did computer systems engineering. Then I went on to do a PhD in AI in a field called multi-agent systems. Again,
Wow.
back then you had to describe to people what that was, and it still felt very strange and distant from reality. Um, I did a few years in academia and then I sort of moved into industry, mostly consultancy, working with government organizations, large corporations, and so on, working the semantic web for anyone that remembers that. Um, and then to get us closer to today, around 2017, started a company, professional services company, building conversational applications, chatbots, and all those things for enterprises. And it's through that experience of trying to use the tools that were out there those days, Google Dialogflow, there's, Lex from Amazon, and so on. And we said, this is all very interesting. The NLP technologies are exciting, but there's a layer missing on top of that we started scratching away at and trying to formulate our ideas around that, which eventually led to the kernel of what is today Open Dialogue. So that's that professional services company that was acquired by a larger organization. We ended up spinning out of that organization to form Open Dialogue and build a product around the ideas that we had.
So I'd love to talk about open dialogue a little bit, but what what piqued my interest was your PhD in multi-agent systems because mine happened to be, I would say, thesis in my master's project, and that was around multi-agent software engineering. And
Amazing.
there it was about the software engineering is moving from monolithic to then it became a little bit more function and modules to then object oriented where the Java packages came. So I was working
Yeah.
with Dr. Scott Deloach, and his hypothesis was that it was agent oriented software engineering where now the packages would be able to run independently and using just TCP/IP, they would be able to talk to each other. So I had created this application based on that as well. But I'd love to hear more about your PhD. How did you get to that topic? What was it about? What was the major thesis around that?
So interesting. It's this is very what a coincidence. It's the same. area of multi-agent systems. My PhD thesis, if I remember correctly, is called Models and Infrastructure for Agent-Based Systems, and it's essentially trying to connect some of the abstract ideas of around what an agent is, what is autonomy. So we talk about autonomous agents, and autonomy is a very broad term that can mean lots of different things to different people. How can you take that and turn it into something that is specific from a software engineering perspective, right? So in the same way, when you talk about object-oriented engineering, you have some clarity around what that means with your methods and parameters and so on. Is that what's the equivalent for agent-based systems? And we actually ended up with my PhD supervisor, Professor Mike Luck. We ended up writing a book which is called Agent-Based Software Engineering, which is
Wow.
all about how you do this.
Interesting, because the thesis that I did ended up being in a chapter of a book called Agent Oriented Software Engineering, also with my advisor, Professor Scott Deloach. But let's talk a little bit more about agent. I think it caught my eye more recently, about 2 years ago, when
Mm.
Harrison Chase, who created LangChain, he wrote, and that's what caught my eye, was agentic systems, where we are moving towards collecting data and then gathering the insights of that data to take actions. And I think that's where kind of the more recent agents and the agentic systems started to come
Yeah.
about. When you think of an agent, if you were to describe it, what comes to your mind? Like what is that cognitive architecture? What does it do? How do you think of an agent?
So it's a very um, at the simplest level, an agent is something that can sense its environment. So it has some capability of being able to take in information. It can make changes to its environment. It has some capability to actuate whatever is required to make changes. There is a level of reasoning within it that would connect that sensing to the acting. And then you get into the more interesting aspect, which is goals. It's trying to achieve something. And I think that is the fundamental difference from other types of software, in that you have this concept of a goal. And the way I would describe a goal is there is a state of the world that it wants to get to. So in the context of like a conversational AI agent, the goal might be, I want to take my user from not having completed their insurance claim to having completed a well-structured insurance claim, right? So keeping it very, very practical. But there is a state of affairs that when I reach, I'll have satisfied my goal. Um, in that process, you could think of multiple goals. You could think of concepts that sit on top of goals, like motivations. I'm motivated to do this in the fastest way possible. So that's going to generate different goals based on that motivation. Or I'm motivated to collect the best possible type of information. So I'm going to ask different questions because of that. But yeah, sensing, acting, reasoning, and then goal directed behavior. Uh,
That's really resonates with how I think about it, except for a couple of other things that I wanted to you to opine on. So, for example, when I think of an agent, what you described is very similar to how humans behave, right? Which is we have the five senses to gather data from the environment, and then some of them to actuate it. So, in the world of an agent, those becomes your sensors. And
mhm.
those sensors could be vision, it could be voice, it could be just input
Totally.
text. And then if you want to affect the environment, then I think that's where, at least in the software world today, that is through tools. So you want to go and take an action in another system.
Exactly.
And I want to come back to one of the tools which has really blown my mind in the last couple of weeks is the computer use tool.
Mm.
But I also wanted to touch a little bit about when you say goals, does that include knowledge and memory, or do you think knowledge and memory is a separate attribute also part of agents? Because at the end of the day, if you want to be autonomous, then you need to remember. That means you need to store session. And you also need to have some specific knowledge because your goal is associated to a specific goal. How do you think of knowledge or the data aspect of what an agent does?
So at a practical software, if we're actually building something, yes, we will need to store information. We need to be able to check back and say, what did our sensor record 5 minutes ago? What did the user say 5 minutes ago? So that we can reason about what we should say now. Look, if we just think of it a bit more abstractly, um, it's not necessary. It's not a necessary condition. I can have a goal without necessarily having even a good way of understanding if my goal was achieved. Right? Like it's almost philosophical, but whether you have knowledge, long-term memory, and so on, those are all capabilities to the service of achieving something, right? So I don't consider them necessary conditions.
I see.
Just if we remain at the level of definitions, but practically, if you're building something, it would be pretty hard to do it without proper storage of information and access to that information and so on.
So let's talk a little bit about the implementation based on your experience. But first, let's talk about Open Dialogue because from what
Mhm.
I understand, it is a platform for building agents. And
Yes.
those agents are similar to what we just talked about, or are those agents also a manifestation of, let's say, a customer support agent? Like, how do you think about Open Dialogue and what does it do, or what can it be used for?
Um, So the answer is yes to both of those things, which is unfortunate and confusing for people, right? Because
Yeah.
we have to look at if we're software engineers or developers or designers and we're talking about AI agents, we're talking about a specific thing.
Hmm.
We still, as a community, need to get much firmer about what we mean, but broadly, we have a sense of what we're talking about. Then there are like support agents that work in contact centers, and you can build an AI agent that does that job. And they're
Yeah.
both called agents. And there's always a bit of a challenge with our customers to sort of separate those things. But in this context, I think we know what we're talking about. So yes and yes, it's AI agents and it's also customer support agents and triage agents and all of that. Now, the one twist to the tale of how Open Dialogue approaches this
Hmm.
um, is that there's actually another agent here in our multi-agent system, which is the human interacting with our AI agent. So
Huh.
and let me give some more context. So the way that we approach the problem initially, and this was 2019. It was before the term AI agent became popular within the context of essentially large language models and generative AI. Right? We were looking at the challenge of conversational AI and saying, part of that challenge is natural language understanding, but the other challenge is how do you engineer the system? How do you think of the component parts of the system? What problem are you solving? Right? And the problem that you have is you have a software system, call it whatever you want, but it's a software system, and you have a human being over here,
Hmm.
and they're going to communicate with each other and they need to coordinate and collaborate to solve a problem, to process that insurance claim, to book that
Hmm.
appointment, to answer that support question, to resolve whatever it is they're trying to do. So wearing my multi-agent systems hat, I said, oh, I've heard of this communication, coordination, collaboration problem before. That describes a multi-agent system. And this multi-agent system has two participants in it, my now called AI agent and my human being. They're both agents in a multi-agent system. And what I am building is not just an AI agent an AI agent. What I am building is a context, a system within which I'm going to place an AI agent, but I'm also going to place a human or more humans or more AI agents, right? If we expand the problem. And I need to provide appropriate control mechanisms and structures and management mechanisms and so on to coordinate all these participants as they're communicating to solve a problem. And we can take that one step further, right? So if you look at multi-agent systems research, there is research that deals with how do you describe this thing. So if you imagine a world where they weren't necessarily thinking of it from the aspect of there's going to be a human and a software system communicating, but they were thinking of it from the aspect of I'll have multiple autonomous entities that I've had no control over. I didn't design them myself, but I'm placing them within a context where they have to follow certain communication norms. They have to be working towards a specific goal.
Mm-hmm.
And that is actually what we do in society. So if you think of how we as human beings coordinate ourselves and manage communication and collaboration, we have this concept of an institution. And we say, okay, and we have more formal institutions and less formal institutions, right? So if I walk into a courtroom is an institution. There are certain rules you're supposed to follow. Each one of us is independent and autonomous in that courtroom, but there is a overarching structure that guides our behavior. And if we're not behaving appropriately, there is the person that's going to say, hey, the judge walked in, you need to stand up, right? Or you need to swear to tell the truth and nothing but the truth, and so on and so forth. You can take this idea of institutions and say, well, what's the computational equivalent of an institution? How would I design it? How would I give it shape? So those were without getting too much into kind of the theory behind it, but those were the conversations we were having early on in Open Dialogue and saying, really what we're building is not just an AI agent looking outwards. We're building a context within which we will place AI agents and we will place human beings, and they need to communicate, coordinate, and collaborate to solve their individual goals. And then there is an institutional goal to be solved as well.
That is a very unique and a fresh look of agents, I have to say, when I hear you talk about it. But it also touches upon one challenge in that if you're trying to build something like that. So the way I think of it is, let's say it's purely AI agents,
Mm-hmm.
and there are humans in the loop. The two ways to do this is one, you create an entire digital context and let the AI agents go achieve that goal based on some instructions. But in that, the challenge is you have a supervisory agent, which is typically not a human, and then they have a bunch of other agents. Now, in that system, the supervisory agent with a large language model, it decides how to break the task and assign the task and so on.
Mm-hmm.
And it's pretty non deterministic in the sense if you give it the same task multiple times, it might do different things. That's the nature of, you know, specifying temperatures or not. So the other way to do this would be a much more deterministic way in a workflow, where you say, no, there are conditions, there are while loops, there are parallel loops, and it's all ensconced into one single quote unquote workflow.
Yep.
Now, what you're saying is really interesting because you're saying the human is part of that context as well, right?
Yes, sir.
So that brings me to the question of, double clicking on each one of these components, both the context or the workflow, as you say, and the agent itself. So when we're thinking about, let's say, an AI agent, it obviously has access to a large language model for quote unquote intelligence and has access to tools. And the system prompt gives you kind of the little bit of context as well as the goals of what it's supposed to do. Is that how you think about going about building an AI agent, or do you have a completely different construct there?
Um, it's it's very similar to that with some important differences. So I think at a broad conceptual level, it's similar, but then the the specific practical problem that we need to tackle, especially since we work mostly in regulated environments, is we need to bring control and predictability into the system. So yes, we need to use large language models because they give us access to language understanding as the main thing for us. They're this wonderful language calculators that can do a whole series of interesting things for us. They can do some basic reasoning. You shouldn't, I think, overly trust on them from a reasoning perspective. They'll easily trip up, but they can do reasoning, and with appropriate guardrails, that can be okay. Um, but we don't think of it, for example, as there is one system prompt that guides everything. There is a multitude of prompts, and this control system that you design as the system designer decides what it should apply at any given point. To give you one simple example, we control explicitly and separately from the large language model conversation history. Uh,
Yeah.
because conversation history, which is obviously very, very useful, if the only way you have to manage that is feed everything into the large language model, you're opening this huge attack vector for the language model, and beyond kind of the security concerns, you're just giving it also this space where it can get confused about what is appropriate. So we bring conversation history control back into the system, and we give developers tools to decide how much of the history they need to feed into a prompt based on what that prompt is trying to do. It might be that it's actually beneficial to have zero history. You don't need to know what happened before. You just need to have some specific attributes of that environment fed into the prompt. You can do its reasoning. It will adjudicate this is true or false, or here's what this means. And then you can pick that information and go on to do something else. You may only want to reason about the history from the perspective of what your agent has ever said, ignoring what the user has said, because that's a more reliable record for a specific context in time. Or you may want to reason about everything. The conversational context and the type of problem that you're trying to solve determines something like that. So we shouldn't, a lot of the ways of solving some of the challenges of building more complex conversational AI agents that guide the user through a series of different steps and they don't get lost and easily confused is I can describe it as making the implicit explicit. If the only tool you have is a big system prompt where you feed what the user said in there, it's going to go through a few pages of instructions typically, right? They're based on AI agents that I've seen out there, at least a few pages of instructions because they're trying to do so many different things. And then it goes into the LLM. The LLM decides a whole bunch of things. It decides what tools to activate and so on. Sounds fantastic as a proposition up front. Um, but actually it's removed control from you as a designer of the system. And the only way you can re-exercise control is extremely costly. It's either keep rejigging this prompt, and praying that it's all going to go well, or you get into fine tuning, you get into all sorts of complex engineering tasks. When if you rethought the problem from the start and say, hold on, do I really need is this the only way to solve this problem? Kind of break it down into smaller problems and put a control structure. And I don't just mean a workflow that goes through one prompt and then the other and so on, but a control structure that talks to me about what is it that the user said. So in OpenDialog, we have something that we call a semantic classifier, right? So everything the user says goes through this semantic classifier. It's a very simple concept, but extremely powerful because it gives us that signal or here's what the user asked a question. This was an opinion. This was something specific about a claim, or actually the user is this was just casual conversation. It was bad behavior. All those things are really strong signals to the designer to decide what to do with them. And they don't have to deal with them in one single master prompt that then decides how to dish the work out to other pieces of the process.
So, how do you then make agents more specialized? Is it by giving it a different large language model and do you fine tune it? Is it by giving it a more dynamic prompt? So, let's take a step back. Let's say I am, as a developer, building a AI agent. And I
Mm.
also wanted your take on some frameworks like Microsoft's AutoGen, there's LangChain, there's Llama Index, now OpenAI has Swarm, Crew AI, and so on. So I wanted to first understand at a very tactical level if you have played around with those, what are your thoughts? And two, more importantly, if I'm building an agent as a developer, how do I give it a different construct or a different personality or a different goal? Is it a large language model? Is it the system prompt or a combination of both? Or fine
Sure.
tuning?
Yeah. Let's start with that, and then I'll talk a bit about frameworks. I see it as a series of um, increasingly more costly activities. Right. So the first tool that you have when you're interacting with a large language model is your prompt. Right. So let's focus on the prompt just for 2 seconds. You can have a static prompt or you can have a dynamic prompt, where it's
Right.
essentially a prompt template. A lot of problems can already be solved simply by having a dynamic prompt, where you can, as a conversation is developing, and keep in mind that in my context, we're focused primarily on conversations, right? There is a user on the other end, and we're having a back and forth, as opposed to an AI agent that is left to,
On
go
its
do
own.
something and come back and report once you're done. So you can have a dynamic prompt, and that already solves a number of issues. The next step is you can say, well, okay, instead of just having one dynamic prompt, I can have multiple dynamic prompts, right? Depending on the context of my conversation, I actually want to change how I'm going to approach some of the conversation. And if I try to do that through a single prompt, I'm limited in the complexity of the problems that I can solve purely by the fact that you're giving these things instructions. And it first of all, it goes back to your ability to write clear instructions. And the more of them you write in a single prompt, the more likely it is to trip over yourself. Right. And we see this every day as we talk to people that are building AI agents, and it's a very simple exercise. So, okay, this is your prompt. Fantastic. Read it out loud. What does it say? If, say, you were just hired by this organization and you were given this piece of paper with the instruction, would you know what to do? And inevitably in this exercise, and the reason we're doing the exercise, the response is, oh yeah, you're right. It's a bit confusing. Right?
Hmm.
So how would you expect a large language model to know what to do, right? And to get predictable behavior from it. So obviously there is the skill of writing more clearly, but then there's just um, over going through the problem completely and saying, okay, instead of writing all these instructions in one place, break it down, right? So there's less of an opportunity for you to trip over yourself. So where did we get to? From a static prompt, we went to a dynamic prompt, we went to a network of dynamic prompts. Um, we haven't talked about knowledge yet. And in this context, for simplicity, let's just keep it to the RAG pattern of saying, okay, um, the user has said something, we can pick that up and do a search over a much larger set of documentation. And this dynamic prompt is not just dynamically updated based on kind of discrete variables, but you also get like a whole set of information. Like here's an entire insurance policy document or a part of an insurance policy document that then we're going to reason over. So now your knowledge is coming from unstructured data, documents that an organization has, and it's feeding into your prompts depending on the context of the conversation. I would like the approach that we suggest is see how far you're going to get with all of this. And most applications these days, that's all you need. The overwhelming majority, that's all you need. If you then identify a specific case where you need something like fine tuning, then you can go and do fine tuning. But think about it very carefully. Do you really need fine tuning, or is there another way to solve the problem? I actually just saw a research paper literally just before this call um, that's comparing the performance of fine-tuned models to the increasingly large language models that we're getting across a number of different domains like medical and so on. And inevitably these days, the large language models are performing better than the fine-tuned models in those domains, right? Because it's just a function of scaling and so on. So while I think fine tuning is something that engineers find very attractive because it's a proper job, it's not writing a prompt. It's you collect data and you do training. It's what we recognize, right? Especially if you're coming from a classical machine learning context. Yes, I
Yeah.
get this. I'm training it. I can see my processor heating up and all of that. This is important work, but it's not necessarily useful work, and it's challenging. It's like we're in a very fast paced world, and it's really, maybe a year and a half ago it was very useful. These days it has changed. So yeah, I would say fine tuning is close to last resort, and then obviously the other thing you can do is come up with your own large language model, which is a huge, extremely costly exercise and just the domain of very few organizations these days.
And if you have a large corpus of data. But let's get to the framework piece. Have you played around with any of these frameworks, both for building AI agents as well as orchestrating them, or do you do everything on your own?
So we've played around with a bunch of different things. We've played around with LangChain, with Llama Index, with a few other tools. Ultimately, I see them as complementary to what we are doing. So we're very focused on how you can create useful, reliable, safe, trustworthy conversations with a user. If you take something like LangChain, and I'm by no means an expert in LangChain, but I see it as this very broad framework coming from my background and the amount of time that I've spent thinking about the concepts and how they tie together and institutions and so on. It's a very agnostic bucket of tools, right? It says, here's a bunch of things, here's all the things. And then you need to figure out how to stitch them together to get something useful, which is fantastic, like extremely useful. We take a different approach. We're saying, yes, there is a bunch of things. We have an opinionated way about how to build conversational AI agents that will get you from A to Z quickly. Because obviously you have to agree with our opinions. If you do not agree with our way of building AI agents, you're not going to have a fun time with open dialogue, right? Because in the way you use any framework, in the way when you're doing programming, you say, oh, I'm going to do object-oriented programming instead of functional programming. But if you hate object-oriented programming, you're not going to enjoy what you're doing very much. You sort of need to play along and agree to the framework's approach. Uh, I think the thing that gets closest to what we're doing is Swarm from OpenAI, in that it talks about different. I'll just call them conversational contexts,
Yeah.
and it attempts that same thing of making the implicit explicit, so then you can feed it into the next bit of the conversation. So it starts to approach what we're doing, and it's unsurprising. I think it came out of the professional services part of OpenAI. They were trying to
Yeah.
actually implement real solutions for their customers. So it's unsurprising that they ended up in a similar place.
Yeah, I played around with it. I like, with most libraries, which is true for even LangChain as well. It's right now very simplistic, very lightweight, and kind of easy to get around. So
Hmm.
let's see where it goes maybe in a few
Yeah.
months or so. But I wanted to get back to the implementation of the way you're thinking about it. If I understand this correctly, the user or the human agent makes it, they are having a conversation that then gets converted into a network of prompts, and these network of prompts changes over each pieces of conversation. Then it goes into another. Does it go into a large language model, or does it go to a quote unquote agent that then goes and does certain thing? Like, how do you see the overall flow in your mind?
So each prompt, when it's executed, it defines the large language model that it needs to use, right?
I
And
see.
that's another aspect of it. So if you think of what you need to do when you're doing a conversational AI agent, um, like for example, I mentioned this classification task. Like every time a user says something, we want to have some signal of what that thing was before we go and do anything else. This classification task, you can get away with something like GPT-4o Mini, right? Which
Mhm.
is faster, cheaper, and so on and so forth. Uh, then, as you're doing your conversation, you may hit a point where you're actually doing a more complex reasoning task, where, say, you're trying to book an appointment with a user, and you're saying, will you be available tomorrow at 5 p.m.? And the user says something like, I have to take the kids to basketball practice. And so that's a more nuanced reasoning task for that specific bit of understanding. You might still use the mini one to say, yeah, the user made a statement about where they're going to be, but 4.0 would be better in telling you, well, does that mean they're going to be at home, or are they going to be somewhere else? Right? Because it's kind of hate using these terms, but you need that broader understanding of the world that large language models can emulate quite well, especially the larger ones, right? So taking the kids to basketball practice means I'm not going to be at home. Great. For that bit, we will use a slightly more sophisticated model. For everything else, we'll stick to simpler stuff.
So, for something like this, do you see overhead in latency because you're doing multiple calls? And we haven't even gotten to the data side yet. But What are your thoughts about latency when you think about this way
Yeah,
of
that's
making
that's the
decisions?
one catch, right? So you have control, you have much more safety, much more trustworthiness. You're doing a bit more work. You're
Mm,
thinking about it a bit more, right? Because, for example, you have two steps. You're saying, "Hey, what was that they just said?" And then, okay, so that's an okay thing to deal with. Tell me a bit more about it. So that's two calls and so on and so forth. So that then the way we view it is, is it worth the hassle?
mm.
Because in an ideal world, you would just be able to say, "Oh, sure, just send everything into a prompt that is multiple pages long, um, that somehow is written with perfect clarity. That even though a human might not understand how it works, an LLM will figure it out, and it will figure out the right tool and just get everything done for you." We don't exist in that world. So, from an engineering perspective, we have to say, no, no, we need reliability. We're going to take a bit of a hit. And then we have other ways of making up for that difference, right? Like we can work on the whole system to make it more efficient and so on.
So, one of the things you mentioned earlier, which I want to go back to because I'm having a similar conversation yesterday, was talking
Mm,
to some very large enterprise companies, and they said the same thing as you did: is we are in a regulated industry. We have zero tolerance for hallucinations, and accuracy is the number one priority. Latency, not so much, but it shouldn't be like 50 seconds of response.
oh, yeah.
So, when it comes to accuracy, explainability, auditability, all characteristics or requirements for enterprise AI, obviously now there are organizations, they have these very long SQL statements, like 16 pages long SQL statement, because they know it goes and fetches the right data and they've been
Mm,
using it over and over. And that they try to just encapsulate inside a function. So you call those functions through function calling, and then you get these answers. But from your perspective, since you are in the regulated industry, how do you prevent hallucinations and inaccuracy? And related to that, do you think retrieval augmented generation at some point just goes away or becomes table stakes for all enterprise AI?
I'll start from the last bit to say that I don't think I know. I think right now it's a very important tool. I can't see it disappearing. Um, it's if the alternatives are something like fine tuning or so on, then no, it's not worth it, right? Like you always need to balance the effort and risk you're taking on one side versus the other side, and I think it's possible to get reliable results out of the capabilities that we have today with RAG and so on. For me, there is an overarching approach here, right?
Mhm.
Which is if you care about safety and trustworthiness, there's two aspects to this. I translate it into control and auditability, right? So, how much control can I bring into the system? Because more control I have, the more trustworthy or the safer the system is going to be, right? If let's just call safety the avoidance of mistakes, right? So the more control I have, the safer it's going to be. What that means is if I'm doing something like RAG, if I can reduce the problem enough, then it becomes very reliable. If I'm doing a search over a huge space, then I'm introducing the possibility for errors to come in and hallucinations and so on. But if I am able to reduce the space considerably, I already do away with a whole bunch of issues. So then that takes you into essential information architecture, right? Do you just have one bucket that you throw everything in? And yeah, Graph rag is sort of that same idea. Do you just have one bucket that you throw everything in, and whatever the user said, you send it to that bucket and hope for the best? Or you structure more complex SQL queries, or you have a more elegant information architecture that starts looking like a graph. And instead of just sending what the user said, you do some processing over all of that. You identify what the actual purpose is. Maybe you even have a conversation upfront with the user, which I think is one of the strengths of conversational AI in that sense, is help the user ask the right question. Right? I don't necessarily know as a user how to formulate it perfectly to get to where I need to be, but the AI agent can help me ask the right question. Right? So all these are levers that you can, or um, sliders that you can move about to say, right, I'm going to break up my information. I'm going to give like a knowledge graph structure to it. I'm going to pre-process what the user said. I'm going to pre-process my content. All of those things are tools that you can use that I think can get you quite far ahead. Then the other side of it, which was one of the biggest challenges for us, is provide a clear, auditable trace of all the decision making along the way. Right?
Hmm.
Because it is not a single prompt that rules them all. That means we're actually making multiple decisions. So a single interaction in Open Dialogue, we're going to be collecting something between 200 to 300 data points at least, right? Of here's all the things that have happened along the way from the user saying something to the application saying something back. Now, if we can store all those different decision points and are able to analyze them and search over them and present them back as a trace to say, here's why we got to this. Because essentially, auditors, the question they're asking is why? Why did this happen? Right? And if it goes into an LLM, that's a very hard answer. Like we're getting tools, and you can sort of start formulating something, but it's very hard to formulate a single clear answer. But if you break the problem down into multiple decision points, it actually starts looking like an old style problem. Yeah, I thought this is what they said. And because I thought this is what they said, I did this extra reasoning. Then I thought this was the consequence of that. So, which is what a human being would say when they're trying to figure out something. It starts to look a bit more like that rather than, this is what the LLM came up with because it was the most likely next token.
So interestingly, Ronald, what you just said about knowledge graph, that's the second time I've heard in 2 days from somebody else I
Mm,
was talking to yesterday as well. And they were describing something similar, is that they are looking at building a knowledge graph almost as a front end to the entire corpus of data.
hmm
But that is a challenge by itself in software engineering. And
Yeah.
this person I was talking to, they've been at it for years, so they've built their own graph system. But I know of somebody else who used something like a SingleStore just as a lookup table to
Yeah.
build it in a much more faster retrieval system. Do you build a knowledge graph yourself? And do you use like a open source graph database, or do you not use a knowledge graph? In which case, how do you go about retrieval of the data in a most accurate fashion?
Um, so we don't use a different graph system. Uh, we maintain our graph, and the first graph that we maintain is actually the conversational graph. The series of contexts and the relationships between those contexts and the things that lie at the same level of the conversation or higher up or further down, right? So there's that first conversation graph, which we store in MySQL, and it was one of our scaling challenges and why we were looking for different storage solutions and ended up with SingleStore, right? the ability to do that graph reasoning in an efficient way. So yeah, we kind of treat everything in a single space, and then there are so we have the conversational graph, the semantic classification of utterances. It's a much simpler graph, uh, but that is like a separate piece of data that we also use. And then the way we treat RAG information at the simplest level, because we are a no-code tool, right? So we're always trying to find that right balance between here's something that you can just get stuck in with and get something useful out versus having to do quite complex coding yourself. So even with knowledge sources, even just that simple structure of saying I have a knowledge source which has different topics, and those different topics have different sources, and I can decide what I'm going to interrogate at any given point, takes you quite far along the path of
Mhm.
solving this problem for a whole bunch of different business processes that you need to automate.
And I'm assuming when you build out the relationships, either in conversations or even in classifiers, do you build your own machine learning models or do you use an out of the box LLM for that too?
Um, so for the conversational structure, it's essentially we have our orchestration engine, and it's explicit reasoning. It's not machine learning based, right? It
Hmm.
is there is this. It's much more like a compiler. Like there is a set of structures and a set of um, uh, operations or commands you can define here. To give you an example, the simplest possible example, right? You can say a certain conversation is appropriate as a starting conversation, right? So this is a behavior that you define within your conversational graph. So you sort of define, here's my entry points. And then conversations break into scenes break into conversational turns, and within turns, you can have different intents, and you explicitly represent possible user intents and possible application intents because they are equal. Right? So you end up with this directed graph of a series of contexts where the bottom leads are your participants in the conversation. And you're essentially saying, given a context, here is what's possible. And I have certain primitives that I can use to dynamically define uh, more interesting behavior than simple if then else. But it is explicit. Um, for everything else, since maybe about 6 months, we're using LLMs. Like every other bit of reasoning that we do, whether it's a semantic classification, um, reasoning about the environment, generating responses to users, and so on, we used to plug into a whole host of different systems. Like, and actually in OpenDialog, we will still find connectors to Amazon Lex and Google Dialogflow. And for those that people still use it, like Microsoft Lewis, like that was your intent classifier, right? So we still have like our hooks into those things because we used to use those things as well. But if I am building a conversational AI agent these days, I, I cannot understand. I cannot find a reason to use anything other than LLMs.
So I know we've been talking, I was just looking at the watch, we've been talking for
Oh
almost
wow!
60 minutes, but this is such an amazing conversation I've had and I got to learn so much. But I wanted to, pick your brain on a couple of things and then we'll get to, some quick lightning round questions. But given your field, your experience, your background, where do you think we are headed in terms of machine learning models versus using out of the box LLMs? Because definitely we are seeing even classification and
Yeah.
specialization and large language models. But I still see people, some of them, building their own machine learning models as well. How do you feel? What are your thoughts on where we are headed?
I think, and this is complete speculation, right? But I think we're going to see two things. First of all, from a large language model perspective, and if you follow the space, there's already talk of this. We're sort of hitting some limits, interesting limits that they're not going to get necessarily much better than what they are already. Um, so I think the space for innovation here is how we use them, because actually we've moved so quickly in getting them better and better and better and scaling them and so on. We haven't actually had the chance to properly catch up in how do we use them. And by that, I don't mean people that live in AI agent frameworks every single day. I mean the rest of the world. Like the majority of the world is not using AI agents every single day, right? The majority of organizations that we talk to don't have anything. They're still trying to figure this stuff out. That's the main thing there. Um, so I think with large language models, the space for innovation is less, GPT-5 or GPT-6 is going to come out and it's even closer to AGI or whatever you want to call that. And it's more about how do we use them in interesting, reliable ways. And then we're going to see a resurgence of the classic, um, let's just call them classic machine learning, because it is extremely useful. It runs a whole bunch of things. We have learned a lot about it. We've been distracted, but there is a lot of problems that you can solve with those things. And I'm sure we're going to see those things come back in and find even simpler ways to make them accessible for people to train and use and so on.
So, one thing I always get asked whenever I'm speaking or when I'm meeting with people is, this is all very interesting. I want to build out some enterprise AI or even agent based architecture. Where do I get started? What's your advice to people like that?
Uh, Also, I'm very biased, but I think if you're looking to do conversational AI agents, so something that's going to talk to your users and so on, I would absolutely recommend OpenDialog. That's a great place. The other thing I would say that's maybe a bit more useful for people is there is a skill of um, how you use prompts, how you use
Hmm.
LLMs, and maybe the place to get started before you dive into just building something is spending some time to understand this how this technology works behind the scenes. Not to you don't need to learn how to you know train an LLM on your laptop or anything like that. I don't think any of that is useful. But having a conceptual model in your head of how these things work makes you such a more effective user of them. That's the first thing. Then the second thing I would suggest is the technologies allow you to move extremely fast.
Hmm.
So actually take some of that time that you've just gained to think more deeply about the problem that you're trying to solve. I see a lot of let's just do something because we can do it in 5 minutes. Look, here's a video clip that says, "Hey, I built something that is does X and Y in 5 minutes. It's amazing." Let's think about it a bit. That's think fast, think slow. We're all in the
Yeah.
think fast space right now. Let's use some of that think slow space and say what's a good thing to build. And
Hmm.
again, going back to where things are headed, that space where people are absolutely starting to spend some more time, those interesting solutions is where I'm sure we will see more innovation. Like I think you mentioned it before we started our chat. Something like was a computer interface from Anthropic and so on. Like that's what can I do with this technology now? That's interesting.
Yeah, in fact, we didn't talk about it, but I've been playing around with the Anthropic computer use tool. And although right now you can run it inside of a Docker containerized, guardrailed kind of an environment, but it's connected to the internet. And I saw it literally break CAPTCHA to go sign up
Hmm.
somewhere. And I was like, okay, this changes how we even think about CAPTCHAs and building
Yeah,
applications and so on.
yeah,
So that to me is one of the most disruptive thing. And now OpenAI introduced the, you know, parts of the computer use where it can see your app
yeah,
and then be able to prompt on it. So it's headed in very interesting times. But
absolutely.
let's move to the lightning round questions. Three simple
Sure.
questions. What's your favorite IDE for coding these days?
Visual Studio, which I never expected, but yes.
What is your favorite AI tool that you use almost every day?
It's ChatGPT. It's always open on the side. Yeah.
What do you do when you're not working or coding?
I have two wonderful kids and two wonderful dogs, and we do all sorts of things together. It's mostly they tell me what to do. I'm just there for the ride.
When do you think AGI would become a reality?
Never.
Perfect answer. And finally, where can people find you if they have questions or comments about this podcast or agents in general?
LinkedIn. It remains the only network I feel I can use every day. I used to be on the old Twitter quite a bit and so on, but LinkedIn, Ronald Ashri and LinkedIn.
Very good. Well, thank you so much, Ronald. I really appreciate
Thank
it.
you.
I thought
It
it
was
was
fun.
an amazing conversation, and thanks again for joining us.
Thank you so much.
Thank you for joining us in this episode. We'd love to hear from you. Leave a comment, share your thoughts, or just ask us a question on the YouTube channel. We'd love to answer it in a future episode, but we'll also answer in the YouTube comment section as well. If you have a guest or an app you'd like us to feature, let us know in the comments as well, and we are also on LinkedIn. If you enjoyed this episode, don't forget to subscribe so you never miss a story from the developers and dreamers shaping our world. And until next time, keep building, keep dreaming, and we'll see you soon.